Okay, we're going to do some basic factoring here. Remember, to factor means to write as a product. The first rule of factoring, and that's all we're going to do on this slide, is to factor out the GCF, and that's it. So in part A, notice that in all three terms, all the coefficients are even, so we can pull out a 2. And the highest exponent of x that we can pull out is an x squared. So our GCF is 2x squared. So if I divide each term by 2x squared, I would get 2x plus 1 plus 4x squared. So again, we have three terms here. So when I pull out a 2x squared, I need to end with let me make that line longer, 3 terms. If you don't end with 3 terms, and namely I'm looking at that plus 1 there, then something went wrong. And that's usually where a mistake occurs, is students see that we pulled out a 2x squared, and instead of a plus 1, they don't put anything. You're not subtracting, you're dividing. In part B, I'll put part B down here. Notice we have a 50 and a 20, just as we had before. The largest GCF, or the GCF of 50 and 20 would be 10. And we have an x squared compared to x, take the smaller exponent, y squared compared to y, take the smaller exponent. So we're going to pull out a 10xy from both terms. If I take a 10xy from the first term, I'm left with 5xy. And if I take a 10xy again by division from the second term, I'm left with 2. Keep the sign the same, the minus stays down. Remember, these could all be checked by distributing through. If I were to distribute through the 10xy to both terms, I get back the original. So you can check these, and you are encouraged to. For part C here, we have a 6, 13, and a 7. The formal name of them would be called relatively prime, because the GCF of those coefficients is a 1. And we have an x cubed, a y squared, and a z. Those have nothing in common as well. So the formal name is called relatively prime, which means the only thing we can factor out technically is a 1. Since the GCF is a 1 and there's nothing else we can do with this, this is considered to be prime. It's already factored. There's nothing else, no other way to write it. In part D, this might look a little crazy. So instead, what if I gave you something like 5a plus, I don't know, ba. So 5 times a plus b times a. Well, these both have an a. So if I pulled out that a, I'd be left with 5 plus b. All right, we have the same format for what I just wrote there. Notice we have the same thing here, x squared plus 40. Since both terms have the common factor of x squared plus 40, I can pull out the x squared plus 40. If I pull out the x squared plus 40, notice I'm left with x. And then what number is right here? We didn't write anything, but there's always a number there. Hopefully you said 1. Keep the sign the same, x plus 1. So again, the GCF of those two terms is x squared plus 40. And you're left with x plus 1. Notice we started with 2 terms, we have 2 terms. Just like in part A. If you factor out something completely, there's a plus 1 left over. In E, we're going orange. In E, the coefficients, the GCF of those guys is 5. And that's all we can pull out. We can't pull out an x. Only the x's are only in the first 2 terms. If we pull out a 5, we're left with x squared plus 5x plus 1. For our purposes, we're done. This does not factor any further for us for now. In the future, you will learn how to factor this and also the thing in parentheses in part A further. But for right now, that's it. Again, the whole slide was to pull out the greatest common factor, which remember, that is the first step in factoring.